All right, welcome back. And in this session, we want to focus on relational operators for matrices, all right, or vectors or arrays in general. In the previous one, we saw the one for scalars. So just to mention that we've already seen all of the relational operators, all right. So if you're looking at this video, because this is on YouTube, if you're looking at this video from elsewhere, then you should look for the previous video, all right, the 6.2 video, all right, so that you can see the list of the relational operators. Here we will just apply one of them or some of them to matrices, and you should know that the same rule will apply for all right, for all of the relational operators. So let's create a matrix. Say we have A, we'll say Randy. Let's say it varies from that, and the size is a 2 by 2, for example. All right. So again, the same in the same way we saw in mathematical operators, the way scalars relate to matrices is exactly the same thing when it comes to relational operators. All right. Scalars always in MATLAB have the tendencies of affecting the whole matrix simultaneously in with respect to a particular operator. So for example, I want to check if all of the values here, all right, I want to check if all the values here are greater than 2. I don't need to say 5 greater than 2, that is the first element here, greater than 2, 1 greater than 2. No, I just need to say A, all right, greater than 2. And what would that give me? That will give me a logical array, okay, with the respective entries being the results for each comparison. So, for example, the first item here, okay, is a comparison of 5 being greater than 2, yes or no, which is true, right? So it's true, that's why it's 1. One here is less than 2, so that's why we have 0 here. And 5 here is greater than 2, that's why we have 1 here. And then this other one here greater than 2, that's why we have 1 there. All right, so you can already see it will be exactly the same thing for all relational operators. All right, so let's check let's do the A Randy again. All right, so these are new matrix A, and this time around let's check if it's different from 3. All right, just to confirm what I'm saying, different from 3. So what will be the result here? Obviously the results will be 0 0 1. What am I saying? 1 1 0 1, right? Yeah, good. So 1 1 0 1, all right, because 5 is different from 3, so we have 1 here. 5 is different from 3, we have 1 here. 3 different from 3, we have 0 here, and so on. Okay, so when it comes to scalars with respect to arrays, this is the way it will behave. All right, if you want to check whether all of the elements of a particular matrix or a vector, all right, is greater than or different from or greater than or equal to a particular scalar, one scalar, don't need to create a whole array for that. Don't need to go step by step in that. Just do this, all right, and it will give you the result at every entry simultaneously. This can be very useful. Okay, the next thing we want to see is comparing arrays and arrays. So if I have A, for example, here, right? Hmm, many times I want to check whether 5 is maybe greater than 2. This first 5 here, greater than 2, all right? And then this other one, I want to know whether is greater than 3 instead. And this other one, I want to know whether it's greater than 4. And this other one, so it means for different entries, I need different comparisons, all right? So for that, we'll have a different array, okay? Let's say Randy of 5 comma 2, and now we can compare both of them. So again, like addition, all right, like element wise multiplication, elements wise division, this will be done what, element by element. All right, so a prerogative, a must, a prerequisite is that the two matrices should have the same dimension, should have the same size. All right, so now if I say A, for example, greater than B, what happens? It gives me 1 1 0 0. So let's check at this level here. 5 is greater than 3, that's true, right? So that's why the first item here is 1. 5 is greater than 4, that's true, that's why here is 1. And then 3 here is greater than 5, no, false. 3 is less than 5, okay, that's why here is 0. And then 1 greater than 5, false. That's why here is 0. Okay, so just to show something, let's try to make b to be maybe a 3 by 3. Okay, and then we now do the same comparison and see what happens. You see that MATLAB tells you matrix dimensions must agree. Okay, why? Because the comparison is done element by element. All right. So yeah, that's that for this particular tutorial. So in the next session will be a very short one. We'll just see how to negate all of these relational operators. All right, so to do the opposite of what we really have, and you will see that in the next tutorial. So see you in the next one.